Chapter 3 Playing with Numbers.
Part 2.
Page 51. 3.3 Prime and Composite Numbers. We are now familiar with the factors of a number. Observe the number of factors of a few numbers arranged in the table here. We have a table with 3 columns. Column 1 heading is Numbers. Column 2 heading is Factors. Column 3 heading is Number of Factors. Let's read the table row-wise. 1, 1, 1. 2, 1, 2, 2. 3, 1, 3, 2. 4, 1, 2, 4. 3, 5, 1, 5. 2, 6, 1, 2, 3, 6. 4, 7, 1, 7. 2, 8. 1, 2, 4, 8. 4, 9. 1, 3, 9. 3, 10. 1, 2, 5, 10. 4, 11. 1, 11. 2, 12. 1, 2, 3, 4, 6, 12. 6. We find that A. The number 1 has only one factor, that is, itself. B. There are numbers having exactly 2 factors, 1 and the number itself. Such numbers are 2, 3, 5, 7, 11, etc. These numbers are prime numbers. The numbers other than 1, whose only factors are 1 and the number itself, are called prime numbers. Try to find some more prime numbers other than these. C. There are numbers having more than 2 factors. Like 4, 6, 8, 9, 10, and so on. These numbers are composite numbers. Numbers having more than 2 factors are called composite numbers. One is neither a prime nor a composite number. Is 15 a composite number? Why? What about 18, 25? Without actually checking the factors of a number, we can find prime numbers from 1 to 100 with an easier method. This method was given by a Greek mathematician, Eratosthenes, in the 3rd century BC. Page 52. Let us see the method. List all numbers from 1 to 100 as given here. We have a box here with numbers from 1 to 100 written in 10 rows. Step 1. Cross out 1 because it is not a prime number. Step 2. Encircle 2. Cross out all the multiples of 2 other than 2 itself. That is 4, 6, 8, and so on. Step 3. You will find that the next uncrossed number is 3. Encircle 3 and cross out all the multiples of 3 other than 3 itself. Step 4. The next uncrossed number is 5. Encircle 5 and cross out all the multiples of 5 other than 5 itself. Step 5. Continue this process till all the numbers in the list are either encircled or crossed out. All the encircled numbers are prime numbers. All the crossed out numbers other than 1 are composite numbers. This method is called the sieve of Eratosthenes. Try these. Observe that 2 multiplied by 3 plus 1 is equal to 7 is a prime number. Here, 1 has been added to a multiple of 2 to get a prime number. Can you find some more numbers of this type? Example 4. Write all the prime numbers less than 15. Solution. By observing the sieve method, we can easily write the required prime numbers as 2, 3, 5, 7, 11, and 13. Even and odd numbers. Do you observe any pattern in the numbers? Two, 4, 6, 8, 10, 12, 14, and so on? You will find that each of them is a multiple of 2. These are called even numbers. The rest of the numbers 1, 3, 5, 7, 9, 11, and so on are called odd numbers. Page 53. You can verify that a 2-digit number or a 3-digit number is even or not. How will you know whether a number like 756482 is even? By dividing it by 2. Will it not be tedious? We say that a number with 0, 2, 4, 6, 8 at the ones place is an even number. So, 350, 4862, 59,246 are even numbers. The numbers 457, 2,359, 8,231 are all odd. Let us try to find some interesting facts. A. Which is the smallest even number? It is 2. Which is the smallest prime number? It is again 2. Thus, 2 is the smallest prime number which is even. B. The other prime numbers are 3, 5, 7, 11, 13, and so on. Do you find any even number in this list? Of course not. They are all odd. Thus we can say that every prime number except 2 is odd. Exercise 3.2. 1. What is the sum of any two A. Odd numbers, B. Even numbers? Two. State whether the following statements are true or false. A. The sum of three odd numbers is even. B. The sum of two odd numbers and one even number is even. C. The product of three odd numbers is odd. D. If an even number is divided by 2, the quotient is always odd. E. All prime numbers are odd. F. Prime numbers do not have any factors. G. Sum of two prime numbers is always even. H. 2 is the only even prime number. I. All even numbers are composite numbers. J. The product of two even numbers is always even. Three. The numbers 13 and 31 are prime numbers. Both these numbers have same digits, 1 and 3. Find such pairs of prime numbers up to 100. Four. Write down separately the prime and composite numbers less than 20. Five. What is the greatest prime number between 1 and 10? Six. Express the following as the sum of two odd primes. A. 44, B. 36, C. 24, D. 18. Seven. Give three pairs of prime numbers whose difference is 2. Remark. Two prime numbers whose difference is 2 are called twin primes. Eight. Which of the following numbers are prime? A. 23, B. 51, C. 37, D26. 9. Write 7 consecutive composite numbers less than 100 so that there is no prime number between them. Page 54. 10. Express each of the following numbers as the sum of 3 odd primes. A21, B31, C53, D61. 11. Write 5 pairs of prime numbers less than 20 whose sum is divisible by 5. Hint: 3 plus 7 is equal to 10. "12. Fill in the blanks. A. A number which has only 2 factors is called a dash. B. A number which has more than 2 factors is called a dash. C. 1 is neither dash nor dash. D. The smallest prime number is dash. E. The smallest composite number is dash. F. The smallest even number is dash.